Ladies and gentlemen, good morning, good afternoon, and good evening. My name is Stefano Polidori from the ITU, and I'm pleased to welcome you to the fourth day of the Symposium on the Future Networked Car 2021. This is the last session this year, and we'll complete our program by focusing on the communication aspects for highly automated driving. Let me thank one more time to our general sponsors, Qualcomm and Xperi, who kindly supported the symposium this year. This webinar is being recorded, and our webpage already includes the presentations given in previous sessions, as well as the full recording of the previous sessions. Two chat boxes are available. Please use the Q&A box to submit your questions at any time. Please do not use the chat box for asking questions, but use it to provide comments and statements or any other administrative issue. I would now like to call on Mr. Russ Schild to moderate our session today. Russ has been involved in communication standards for over 40 years. In ITU, he is the chairman of the Collaboration on ITS Standards platform, which, by the way, will have a meeting tomorrow, and everyone is invited to attend and hear the latest ITS standardization development. Russ also contributes to the organization of the ITU UNEC Symposium on the Future Networked Car. I'm very pleased to welcome Mr. Russ Schild at this year's symposium.
Thank you, Stefano. Welcome everybody, wherever you are, morning, afternoon, or evening. I look forward to making this a very useful session to you. I'm very pleased to see that hundreds of people have registered for today's event. To start, I am happy to have my friend Nakul Duggal of the Qualcomm. Nakul is Senior Vice President and General Manager of Automotive for Qualcomm, where he is responsible for Qualcomm's automotive strategies, automotive semiconductor and software portfolio, and ecosystem development, program management, and customer relations. That's a mouthful, but he's really a very knowledgeable senior person, and I'm pleased that he accepted our invitation. Nicole's responsibilities include focused development expansion into the digital cockpit, smart transportation and the connected car, as well as autonomous driving, oversight over product roadmap and its execution, customer-focused business development, and applications engineering. Nakul has worked in Qualcomm Automotive since 2011 and has been instrumental in building the company's automotive portfolio and global insight. He joined Qualcomm in 1995 as an engineer focused on the company's commercial base stations and infrastructure. Nakul will join us for the Q&A after the break. We will have Nakul's presentation, and then I and the other panelists will make opening presentations. We will have a break, and then approximately at 2:30 Geneva time, we will have the full Q&A with Nakul. So please, everybody who has questions, put them into the Q&A that you see on the bottom of your screen. General comments can be put in the comments, but they will not be addressed. All questions, I'd appreciate it if you can put them in the Q&A. So with no further discussion, let's move forward to hear Nakul's opening presentation.
Good afternoon, everyone. Welcome. I'm Nakul Duggal, Senior Vice President and General Manager of the Automotive Business Unit at Qualcomm. I'm very happy to be with you today to kick off day 4 of the 2021 Future Network Car Symposium with a focus on communications for highly automated driving. Before we dive deeper into this topic, it's important to take a quick step back and provide some additional context and more background to get a better sense of why advanced communications for automated driving is so important going forward. As previous speakers have noted, the auto industry is going through an amazing transformation, and it's being driven not only by advanced communications and automotive technologies, but by rapidly shifting expectations from drivers and consumers as well. Today's consumers expect vehicles to do more than transport them from point A to point B. They expect smartphone like experiences while driving, creating a market for virtually always connected digital cabins for infotainment, real time navigation, informational safety, productivity, and more. By 2027, analysts predict nearly 75% of all vehicles sold will come with embedded connectivity. So, automakers are increasingly looking at these connected experiences as a way to differentiate their offerings, grow market share, and strengthen or reinforce their respective brands. The net result of these shifting consumer expectations, combined with advanced communications and automotive technologies, is this: cars are becoming more connected, more autonomous, and more electrified. Advanced connectivity technologies like 5G and CV2X are helping drive this disruption, which in turn affects the demands and expectations from next generation digital cockpit platforms, driver assistance and autonomous driving solutions, and car to cloud services designed to keep connected cars stay updated with the latest software, activation of new services or features, and much more. Qualcomm delivers leading solutions across each of these areas because we view them as an interconnected system, one that seamlessly and constantly helps connect the modern car to the cloud and everything else around it. The auto industry has been laying the foundation for highly automated driving for a number of years. Cars are now more intelligent, new sensors provide enhanced safety features, and advanced AI using high performance, low power solutions like our Qualcomm Snapdragon Ride platform are helping Level 2 Plus ADAS comfort and convenience features gain significant traction, while clearing a path for Level 4 fully automated driving solutions. But again, we see ADAS and automated driving as just one part of the interconnected system that defines a modern connected car, with communications and connectivity as a key to making the entire system work effectively. During our Automotive Redefined Technology Showcase in late January, Qualcomm President and CEO-elect Cristiano Amon emphasized the importance of 5G and the impact it would have on multiple industries, including automotive. With 5G and cloud connectivity, vehicles will no longer be limited to what you drive off the lot. Vehicle software can be updated over the air, adding new features or services to the car. And with access to real-time analytics and applications, new entertainment and service opportunities become possible as well. But for our session today, we are focusing primarily on what 5G communications brings to highly automated driving. 5G will help bring about new direct communications capabilities for highly automated driving, like higher throughput, enabling sensor sharing, coordinated driving using on-the-fly connectionless groups, and higher situational awareness for enhanced ADAS functionality and automation with real-time 3D high-definition map updates. Together, these capabilities will combine to make automated driving safer, more efficient, and most importantly, a reality in the not-too-distant future. At Qualcomm, we believe 5G is for all cars, and the industry is moving forward with 5G as the next-generation connectivity platform. In fact, we see adoption of 5G among automakers ramping even faster than 4G. But highly automated driving requires both the high-speed, low-latency connectivity of 5G, as well as a robust, scalable, and flexible ADAS solution. So starting in the first quarter of this year, customers will be able to get our Snapdragon Ride platform with advanced SoCs, accelerators, and multiple functional software stacks, making it a complete platform for the auto industry to do one-stop shop development for their next-generation vehicles. We are rolling out these functions in a phased approach with the Vision Stack for Level 2 Plus highway automated pilot functions on 8-megapixel cameras available to customers. And throughout the remainder of 2021, we will be integrating more functions like parking assist and traffic jam pilot, leading to complete end-to-end data collection and mapping tools that will take advantage of 5G connectivity as well. ADAS and automated driving features are becoming more and more prevalent in cars today. Active safety features are standard in most new vehicles as they roll off assembly lines. Convenience features are becoming standard, and advanced self-driving features are making their way into a growing number of vehicles. Over-the-air software updates allow these features to remain fresh over the life cycle of the vehicle. When combined with the foundational technologies of 4G and 5G that Qualcomm has pioneered, as well as the building blocks of telematics, digital cockpit, ADAS, and car-to-cloud services, you can see why we view the path or evolution towards automated driving as being off to a great start. But the full story of communications for highly automated driving is not complete without another fundamental building block technology from Qualcomm, cellular V2X. CV2X is a complementary non-line-of-sight technology designed to improve safety, relieve congestion, and make next-generation transportation networks and vehicles more aware and more intelligent about their surroundings. CV2X provides enhanced range for direct communications without network assistance, including vehicle-to-vehicle communications for collision avoidance, vehicle-to-pedestrian communications for safety alerts, vehicle-to-infrastructure communications for traffic efficiency and reduced congestion, and vehicle-to-network communications for real-time traffic routing, navigation, and cloud services. CV2X is standards-based, with broad support from the 5G AA and standardized within 3GPP. We've had global trials and deployments underway worldwide since 2017. With CV2X, roadways can be made safer and traffic can be reduced, easing congestion and lowering emissions. For pedestrian detection and warnings, a roadside unit or RSU using artificial intelligence for camera perception can detect a pedestrian intending to cross the street. By using CV2X direct communications, the RSU can broadcast an over-the-air warning to alert cars at the intersection and provide them with the vicinity of the pedestrian. Roadside units can also broadcast over-the-air messages related to time-to-signal changes, leveraging SPAT, or traffic signal phase and timing messaging. This will help letting the drivers know when the traffic signal will turn green or red. This was just an example of a CV2X communications use case. To give you a better understanding of the wide-ranging use cases of CV2X in regular or automated driving scenarios, we've included a video from our Automotive Redefined event that showcases CV2X use cases from recent demonstrations and deployments in the US, Europe, and China. Take a look. As you can see, CV2X brings a number of safety and driving efficiency use cases to individual drivers. But it's also important to step back and look at the macro level or big picture benefits of CV2X, 5G, and automated driving for intelligent transportation systems. 5G and CV2X direct communications will help share information between cars and other roadside units, like surveillance cameras, construction zones. This will enable greater safety and support for a more coordinated driving experience for everyone sharing our roadways. These enhanced V2V, V2I, V2P, and V2N communications will help usher in a new wave of connected car services and in-vehicle experiences, enhancing road safety, connecting road sensors, and helping improve transportation efficiency overall. When combined and viewed as an interconnected end-to-end system, 5G, CV2X, autonomous driving, and car-to-cloud services can enable an intelligent transportation system that can provide key benefits in the near future. These include safer roads through truck platooning, driver monitoring, and minimizing manual operations to reduce human error. Travel times can be reduced as well, resulting in lower emissions and a cleaner environment. Personal mobility is enhanced too, with new mobility services, assistive technologies, and advanced route planning available to drivers. And a world of new business opportunities may arise as well, from parking and mapping services to fleet management and new streaming entertainment or productivity services for the car. I want to sincerely thank you all for your time today. It's been a pleasure kicking off day 4 of the Future Network Car Symposium with our overview of communications for highly automated driving. With more than 20 years of automotive industry experience, Qualcomm is in a unique position because we deliver leading solutions across virtually all of the technologies that make connected cars and automated driving possible. Telematics, digital cockpit, car-to-cloud, the foundational technologies needed for autonomous driving and driver assistance, and of course CV2X. All of this is running on the foundation of mobile technologies like 4G and 5G that we've been pioneering for decades. Again, from everyone here at Qualcomm Technologies, thank you and enjoy the rest of day 4 of the 2021 Future Networked Car Symposium.
Thank you very much. That was really a great introduction to the whole area of communications for automated driving. So at this point, I would like to go ahead and provide the update of the whole session. My slides are there. So if you could go to the next slide, talking about, first of all, this session is aimed at products for series production vehicles. That is the vehicles that are purchased by consumers and businesses to be driven by people. Go back to the previous slide. No, previous slides. Slide 2. Slide 2, there, thank you. Sorry about that. We're working through technology always on these things. The series production vehicles are different from specific vehicles for specific purposes. That's another major application area for the automated driving capabilities. For robo-taxis, our delivery vehicles or shuttles, that's another area. We have too much to cover for just the consumer vehicles, series production vehicles. You'll see the abbreviation SPV that we will cover today. And the technology is what is called now in our regulations automated driving systems. Those of you who heard previous sessions of this year's FNC would hear about Reg 157, created by UN on automated driving systems. That's the term of art that we will use for the future. And to note it, for series production vehicles, automated driving systems can be used in appropriate areas depending on their operational domain. So they also, those cars will allow people to use it. So the possible technologies and applications that we know about were covered very well by Nakul. We certainly have updates of software. They will be done over the air. We will have updates of the road data, maps in some people's terminology. We'll certainly have updates sent to the vehicle about the conditions on the road. Is the road slippery, or is this road closed because of a sporting event or other things? We will have communications between the vehicles and what we call vulnerable road users, another term you'll find in the automated driving world that we're full of abbreviations and special terms. But that can be cyclists, it can be police or fire or ambulance or other responders, it can be pedestrians, so that the automated driving system will know about these things, not only from what they can see, but also what can be sent to them. An important part that we look at, another one of these terms of art in our thing, signal phase and timing. That's the traffic signals sending messages saying that they are currently red or currently green and will turn to yellow in 5 seconds. So we know when to start slowing down the vehicle automatically for the lowest use of energy. We certainly will have ways where in serious situations, we may be able to have somebody in a control center be able to provide assistance to the driver or control of the vehicle, including some systems that we've already seen in the market where you can get out of your vehicle and remotely control it to park. Those kinds of things will continue. All right, next slide. We will have direct innovation besides with in the previous slide that I covered with things that are not vehicles, between vehicles. We will see efforts for avoiding collisions, cars warning another car they're getting close. We will certainly be providing messages telling cars behind us that we're starting to brake. We need very, very much merging assistance and a heavily congested highway where I'm trying to enter in an automated vehicle. I need to be able to communicate with other vehicles, so one vehicle will give me 4 meters to be able to merge in. Where we come to intersections where 2 cars come at about the same time, they will need to communicate to tell the others here is specific things. I'm going to go first, you're going to go first, or other things. And certainly we will have many dynamic situations. There'll probably be a special dynamic communications capability for automated vehicles to let us know things like we're coming over a hill, but there are stopped cars immediately on the other side of the hill, so you better start slowing down. All of these things will occur sometime, and a lot of what we're going to discuss today is when and how these kind of things will happen. Will they be 2025? Will they be 2030? Will they be even later? And unfortunately, some of them will be later than 2030. All right, next slide. One of the issues that we have to pay attention to is when and where and for what things will we use communications and will we have communications. That's a topic that, again, we will discuss in this session. Different types of roads, expressways, farm roads, city roads. Is it day? Is it night? Is it snowing? Is it raining? All kinds of different things will be handled at different times as we roll out automated driving and the related communications. Next slide. What do we need to do to make automated driving systems work in series production vehicles? That's another topic we are going to cover today, and that can be in standards, can be development of technology, it can be regulations, it can be government assistance and guidance. Do we have to do new infrastructure? And very important, when are we going to have enough to really have a critical mass deployed of automated driving for it to have a big impact on environment, society, and other things? These will be discussed in this session. Next slide. When and will they be happening? A very clear topic that we want to cover today. For the applications, what are the operational domain areas, both motorways, rural, surface, by region? Do they roll out in developed countries at some time? Will they roll out faster in very developed countries versus developing countries? All of these are subject to discussion. Next slide. What do we need in the way of communications capability to make these things happen? What do we have to have for in-vehicle processing? What kind of data communications do we need? Talked about cellular, Wi-Fi. If I have a garage, can I download updates to my software in my garage by Wi-Fi? Nicole was very clear about cellular V2X. It's a major thing. What do we have to do for the people who are going to process things in the background to understand updates of map information? Or road closures need very strong, reliable processes, structures. You listened to session 2, talked about the cybersecurity. Cybersecurity for your smartphones and PCs are important. Cybersecurity around vehicles is even more important because hackers can actually kill people once we have automated driving. So we have to be absolutely sure that we get the cybersecurity. And certainly lots of data comes from cars. There's very legitimate concerns about data security. We have to be very careful that data that comes from cars may say that the road's slippery, but not identify what vehicle found that the road's slippery or other things. Next slide. Okay, that is sort of my summary of where we are going today, what we want to cover. Encouragement for people to put questions in the Q&A, not the chat, in the Q&A, please. I see that there's already 10 questions that we will review. We are now going to move forward with our panelists, and I will introduce each panelist as we go. Our first panelist is Fan Ren. Dr. Ren has been working in Shanghai Automotive Corporation since 2010. During 2016 to 19, she was vice president of Sheng'an's U.S. R&D Center, responsible for R&D of intelligent vehicle technologies. Now she is the manager of the technology department of Sheng'an Automotive Group in China, focusing on software development of connected and automated vehicles. She is also in charge of conditional autonomous driving program, which targets the next generation of connected and automated vehicle platforms and productions. Dr. Ren, please go ahead with your presentation. Please bring her up, slides up for her to use. Thank you.
Hi, everyone. This is Fan Ren from Automobile Corporation. And this is my honor to share some considerations about the communication and connectivity for autonomous vehicles. Next slide. Next slide, please. In my point of view, I think that connectivity brings some new characters to autonomous driving. First of all, the collection based on cellular network makes the system possible to keep growing by the software update and the data collection. And the second character, the cooperation between vehicle and infrastructures extends the service to the vehicle and even make the autonomous vehicle more intelligent. The collection made via cellular communication or C-V2X communication. And the third one is the enhanced safety by cooperation between vehicles. Definitely, via the robust and the low latency dedicated communication. Then I would like to share some view or points about these new characters and some practice of Chang'an Automobile in the following slides. Next slide, please. The first character introduced by the connectivity is growth. There are some reasons and motivations. First of all, it's one of the users' requirements. The users, especially the young generation customers, they expect to have the same experience as smartphone in the intelligent autonomous vehicle. They expect the software can be updated. They expect the post-purchase feature enhancement is available. They expect the system become more and more robust. So this is the one reason. And the second reason, the second motivation is from the OEM. The OEMs want to create more values from the same hardware platform, which is expensive with big computing power. Take Chang'an's car as example. The price of vehicle models is ranging from $18,000 US to $23,000 US. And the level 2 plus autonomous system will take around 10% to 20% of the cost. So we are trying to create the technical possibility to add more features based on the same cameras, based on the same domain controllers. We are exploring some new business models to earn money from this system. So we want the system can grow. We can earn money from these new features. The third reason, in my opinion, is a high-level autonomous technology is not that mature. Now, we even say that it's a high-level autonomous driving system, but it's still kind of driving assistance, very advanced driving assistance system in the vehicle. So this technology will take the time and the date to be mature. So this is the reason we think why we want this vehicle, this system, keeping growing up. And to support this type of autonomous driving system, of course, the software can be updated. The HD map or ADAS map can be updated. And the configuration information can be loaded into ECUs. One special thing for autonomous driving system is that there are a few associated ECUs in this system. Between these ECUs, the signals are exchanged. When a new feature is enhanced or updated, the associated ECU should be updated in the same time. To be more specific, when you enhance the autonomous driving features through over the air, you may update the software of the autonomous driving domain controller, the smart sensors, the gateway, the infotainment system, the instrument cluster in the same time. So this makes the system level solution very complicated, and also the size of the software package is large. Furthermore, in terms of the development methods for an autonomous driving system, data-driven development is the trend. The data of the EDR, the vehicle working status, driving habits, raw data of the sensors, and etc. is collected to develop new features to improve the performance of the existing autonomous system, to validate the system. According to our estimation for our next generation autonomous vehicle, in the early stage, that's around 10 gigabytes data will be collected to the cloud. So this is the amazing size of the volume of the data. So we are thinking to achieve such kind of feature that low latency, high bandwidth cellular communication is a foundation, and the amazing data volume should be supported by new business models. Next slide, please. So according to China's practice, there are some points I would like to share with you. First, our first step is the one to all of our vehicles to be collected. So by 2020, all China's vehicles are networked, no longer produce long collected vehicles. This is the first point. And the second one, we found that the external network like the 4G, 5G can meet our requirements. However, our bottleneck is the internal network and the E-architecture. Why? Because in our vehicle models, we keep a few variants of each vehicle models, the low level, mid level, high level, and even more variants. So the E-architecture is kind of distributed and some kind of integrated type, but not the centralized or zonal type. So it's more challenging to have the vehicle-wide software updated or data collection. Next slide, please. Then the second character is a service extension based on the V2I. So which scenarios should be delayed? Our point is that the more complicated the road conditions are, the more V2I based service is needed. Why? It's because that we're thinking that in the simple scenarios, the active sensors can make a good effect, but in the complicated scenarios, the communication can help a lot. So in our point of view, we think that we have better to deploy the V2I service to parking areas first, then to urban, then to highway. This is also the point we proposed to the Chinese government. Now, Chinese government have been promoting a few pilot projects on highway and the city area already. For example, China's longest and the most complicated intelligent highway will be completed in 2021. It is around 128 kilometers and 47% are tunnels and bridges. And there will be more than 300 RSU will be equipped. And there are around more than 10 cities in China. They have the demonstration areas for the smart road and the collectivity for the test for the collectivity car. And a few enterprises had some demos in parking areas to provide the demos like the reservation for a parking slot or the map distribution. So this is the kind of status in China. Next slide, please. And what China have done, first is that we build up our smart campus and not the build up, we just modify our campus to a smart campus and the parking slots in our R&D center to be a smart to be collected. They have more than 80 smart RSU has been equipped in our campus and parking slots. And we join in the demonstration activity of L4 level road intelligent vehicles and other demonstration in China. Next slide, please. The third character is enhanced safety by cooperation. In our concept is that if we want to talking about if the autonomous vehicle, the high-level autonomous vehicle can drive better than human being, that the communication is indispensable because it has the capability to sense the long line of sight scenarios. So if we were aiming at the autonomous driving in all conditions, the communication is necessary. According to public information, publication from Waymo, now we can see a few collision and minor contact events in automated driving tests are published. So there are, in this slide, there are 3 examples here. We can see that all these scenarios can be really covered by the sensors like LiDAR cameras are used on Waymo's autonomous automated car. Even it's already a kind of high level of autonomous vehicle. So we still think that if we want to get this kind of enhanced safety, with the communication, the V2V application should be deployed. The next slide, please. Because the V2V standard has not been really released in China, so in the past 10 years, the Chang'an lead or participant a few of the Chinese government funding projects trying to get some research, have some research and development activities in collected automated vehicle areas. And we also join and lead some of the to establishing some Chinese national industry standards. And we also have developed the 13 V2X applications in-house. This is what we have done in the past. Next slide. This slide is also the last slide. So when we're talking about these 3 characters, we want to know when we can see those new characters in production vehicles. So my point of view is that I'm thinking that we can see the character of growth very soon because the OEMs have enough motivations. They will make their car to be very open to be collected and have the better e-architecture. It will be a very popular characters in most of the new production cars in the next 2 years. This is my point of view. And for the V2I service, I think this is be leading or driven by the government at this moment, like in China. So because the Chinese government, they want to advance its transportation to digitalization and the use of the artificial intelligence, and the government would like to invest for the infrastructure. So my estimation is that around 2023 to 2025, that we will see some real production in the market. But for the V2V, the enhanced safety, my point of view is not that optimistic because it will be driven by the industry. So I'm thinking that if we will see the real production, the massive production, that will be after 2025. That's my view. Okay, that's all my the points I would like to share with you. Thank you.
Thank you very much, Dr. Fan. Very good discussion. Now we will forward to our second presentation from Mr. Ogawa. Ogawa-san joined Mazda Corporation in 1984 to work in the Electronics Development Department for Multimedia and Navigation Engineering. In 2005, he was dispatched to Mazda Motor Europe R&D Center as Deputy General Manager to be responsible for vehicle research. In 2009, he returned to Mazda Corporation and managed advanced driver assistance development in the Vehicle System Development Department. Since 2015, he has been working on ITS research in the Technical Research Department of Mazda Corporation, Tokyo headquarters. Gawa-san is a member of the SIP ADAS project of the government of Japan, and I will add that this SIP ADAS is one of the world's most important cooperation working on the development and structures for automated driving. I've been pleased to be a speaker at it in previous times and hope will come again once we can all travel. Ogawa-san, please go ahead with your presentation.
Okay, thank you very much. Introduction. I'm Norifumi Ogawa from Mazda Motor Corporation and the chief of the SIP ADAS task force on V2X communication for the cooperative driving automation. Today, I'd like to introduce the use case for cooperative driving automation examined by the SIP ADAS task force. Next slide, please. This is the content of today's presentation. Next, please. First, I'd like to introduce SIP ADAS. The SIP means the Strategic Innovation Promotion Program, which is a joint project of technology development by the government, industry, academia, founded by the government of Japan. The SIP is the project of automated driving system for the universal services in SIP. SIP ADAS aims to realize safe and secure mobility through the practical application of the automated driving. In order to realize automated driving, the competition among automakers is required, and the technological development in cooperative area, such as infrastructure development, standardization, and the elemental technologies promoted by the SIP ADAS is also required. Today, I'd like to introduce the research on the communication methods for the cooperative driving automation that SIP ADAS is now working on. Next slide, please. I'd like to explain the current status and the challenges toward the realization of CDA. As you may know, in Japan, ITS wireless communication has already been put into practical use at the ETC for collecting tolls on the highways and distributing road traffic information. And also as ITS Connect for supporting the safe driving and so on. On the other hand, in the future, more advanced automated driving is expected by utilizing communication. In order to realize the advanced automated driving, communication technology is essential. There are various discussions about whether ITS wireless communication, which is currently in a practical use in Japan, can be used for the cooperative driving automation. And if it cannot be used, what kind of communication method is optimal for the CDA? But it is still unclear. Therefore, in 2019, SIP established the task force on the V2X communication for cooperative driving automation and started studying communication method for CDA. Next slide, please. task force has been researching a communication method in a step from phase 1 to phase 3. First, as phase 1, we defined the system of CDA. Next, we developed the use case according to the definition. In phase 2, we will define the communication requirements according to the use cases and clarify the issues when we applied communication requirements to existing ITS wireless communication. In phase 3, we will verify the validity of the countermeasures through simulations and experiments to solve the issues clarified in phase 2. Based on that result, we will propose the communication method, including a spectrum required for the CDA, and show the time frame when a new communication method will be needed on the roadmap. At this point in time, the phase 1 has been completed and the use case for CDA has been created. I'd like to introduce the use case and show you the next step. Next slide, please. This is then an overview of the SIP use case for cooperative driving automation, first edition. This document has already been published on the SIP ADAS homepage. English version is also available. This is the table of content. I'd like to introduce only section 3 due to time constraint. If you are interested in this document, please visit SIP ADAS homepage. Next, please. This is the definition. The system definition is very important, and I think it is a basis for the considering the communication method. I read the definition. Cooperative or automated driving system is that enables safer and smoother automated driving control based on the autonomous driving system by obtaining the information not detected by the in-vehicle sensor, by providing the information possessed by the vehicles, and by communicating mutually by using V2I and V2V. As you know, it is difficult to guarantee 100% quality of information transmission by radio communication. So we thought that the automated driving control that relies only on the information from the communication would not be possible. Therefore, basically, automated driving control must be done by the information from the in-vehicle sensor, and the information obtained by communication should be used to the support on a safer and smoother automated driving. Next slide, please. As a result, 25 use cases were selected as a feasible, classifying them according to the definition. There are 14 use cases that require the information not detected by the in-vehicle sensor, 4 use cases that require the information possessed in a vehicle, and 7 use cases that require mutual communication by utilizing a V2I and V2B. We will clarify the communication requirements for each of these. Consider what kind of communication method will satisfy them. The next, please. Taking the use case of merging as an example, I'd like to show a roadmap of functional changes by the penetration rate of the vehicle with CDA, the complexity of the traffic environment, and the difficulty of communication. The penetration rate on the horizontal axis can be understood as a time frame. If the penetration rate of the vehicle with CDA is low, information will be provided mainly from the infrastructure, and if penetration rate increase, it will be possible to communicate with V2V. At the first stage, we considered a use case what the merging vehicle adjusts to the main lane vehicle's speed based on the speed information measured at the one point on the main lane. We are verifying the system in a SIP field operational test currently being conducted in Tokyo. If the traffic flow on the main lane can be measured in a certain area, the merging vehicle will be able to control the acceleration and the deceleration for aiming the gap between vehicles on the main lane. In addition, if the penetration rate increase, it will be possible to recognize the merging section situation by the control center, and the control center will be possible to instruct the optimal driving plan to the merging and the main lane vehicle. If the penetration rate increase further, it will be possible to negotiate between vehicles to make mutual concession during the traffic jam. According to the use case change, the demand for communication performance increase, and it is necessary to consider the communication method that can meet these use cases. We'd like to clarify how long the current ITS communication can be applied and when a new communication method will be needed. Next, please. As a next step, we are trying to identify the communication requirements, and we will clarify the issues that in this fiscal year. And we will propose a communication method and a roadmap applicable to the CDA in this year through technical verification of a communication method. Next, please. Regarding the next step organization, the phase 1 has been promoted by the ITS-related ministries, academia, and the Japan Automobile Manufacturers Association. But the studies after phase 2 require the specific CDA technologies, infrastructure technologies, and the communication technologies. Therefore, in addition to the members of phase 1, the members of National Institute for Land and Infrastructure Management, UTMS Society of Japan, Japan Electronics and Information Technology Industries Association, ITS Info Communication Forum, and Society of Automotive Engineers of Japan participated in the task force. Next, please. In summary, the SIP ADAS has begun studying communication methods for CDA. We have completed the development of use cases that will be the basis for the next research, and it has been published on the SIP ADAS homepage. We hope you will use it. In this year, we will clarify the communication requirements based on the use cases and whether it can meet existing ITS wireless communication specification. If it is not applicable to existing ITS wireless communication, we will consider a new communication method and propose it with a roadmap for future CDA. Thank you very much for your attention.
Thank you very much, Ogawa-san. It's really a great project and a great effort going on in Japan on this efforts, and all of us around the world are learning from your activity. Next, I want to go to Meo Yuan Chui. Dr. Chui is Senior Research Director of the Automated Driving Department in the Intelligent Connected Vehicle Development Institute of China FAW Group. He joined FAW in 2004, engaged in automotive electronic control software development, automotive electronic and electrical architecture design, and automated driving system design. Now he is responsible for the automated driving system and product design of the Red Flag grant. Please go ahead with your presentation.
Thank you, Mr. Ross. I'm very happy to participate in the symposium and share with you some ideas on automatic driving. The topic I talk is highway pilot, for short HWP, for series production. And next slide. Okay. First, I want to introduce the evolution trends for automatic driving. Second, analysis. Second, can you go to previous? Yeah. Second, analysis the HWP current situation and the problems. Then give the suggestion on implementation path. At last, give a short conclusion. Next slide, okay. Now, let's give a production of L1 or L2 level automatic driving begins, and the era of level 3 and level 4 is coming. Some demonstration for different applications have been able to experience, such as the valet parking, robot taxi, and the HWP. The second trend is, we can say the 5G has come. Human vehicle road cloud cooperation. Intelligent transportation is expected in the future. It will be greatly improve automatic driving. Next slide, please. For software, the rapid development of big data and AI technology enable automatic driving. For hardware, more and more powerful chips, and the 4D reader, and the LiDAR, and the high pixel camera, etc. This accelerated the landing of autonomous driving. Next slide. There are two ways to realize autonomous driving. For traditional OEM, working on two lines, product development of two consumer end and application demonstration of two business end. For internet technology companies, relying on their own software development advantage, leap forward development route, just like climbing mountain. OEM walk step by step, but the internet technology companies take a leap forward in other direction. Next slide, please. Regarding automatic driving market segmentation. For low speed scenario, AVP, automated valet parking is approaching, and it is expected to take the lead in commercialization because it is not an open road. The impact of regulations is relatively small. For medium speed scenario, the next goal for robotaxi is to improve the safety driver in the regional demonstration. For high-speed scenario, TJP, traffic jam pilot, and HRP, mass production development waiting for regulatory approval. Next slide. Now we analyze HRP current situation and programs for serious production. Next slide. First, let's look at what is the HRP. Be able to drive on highway or urban expressway at a speed within the speed limit. The driver must actively activate the system, but does not have to continuously monitor the system. The driver can take over the system at any time. When the system sends a takeover request to driver, enough time will be reserved for the driver to take over the driving task. If the driver does not take over the driving task in time, the system should implement the risk mitigation strategy in time. It is a typical L3 function. In general, automatic speed is 60 kph to 120 kph. Scenarios that can be implemented include up and down the ramp and the lane changing, etc. Next slide. Now we look at HRP application situation. For regulation and standards, relevant laws and regulation on automatic driving below 60 kph have been issued. UN R157 LKS. It is expected that relevant allocation and operation may start in Europe, Japan, South Korea, and other countries in this year. China has been organizing relevant demonstration application preparation and plan to support its survey as the basis of road test and demonstration application road. Next slide. For HDA map, it provides auxiliary location and priori knowledge, which is closely related to the safety of automatic driving to make up for the limitation of sensor perception, distance, and perception accuracy. The HD map data counts the national areas and the urban areas, and the update the frequency is quarterly. For smart highway road in China, many cities have also carried out the construction of CV2X smart highway road, which are to realize vehicle road collaborative and automatic driving. Next slide. But HRP also faces some problems. First, we can say the lack of policies and regulations for HRP on the road permission. At present, the license issued in China are test license, not operation license. Commercial deployment of HRP cannot be carried out. Second, lack of accurate dynamic information. For example, temporary construction, weather and accident information, and slippery roads and icy cannot be identified and handled. Third, 5G and 4G coverage is insufficient, and there is no GPS enhancement measure in the channel. The fourth, the update frequency of HD map is slow, and it is updated on a quarterly basis, which cannot beat the real-time precision. Next slide. Suggestion on implementation path. Next slide. For serious production, I gave the suggestion to realize the HRP. There are two stages. In the near future, I think the HD maps are updated from the quarter to March. Secondly, the part of the dynamic information exercise where CV2X, such as the traffic accident and road construction, the information can be provided by the CV2X. And expanded the coverage of RTK and build the 5G cloud platform to realize data execution and access function. For in the medium and the long term, HD map maybe it's updated monthly to weekly until it is updated in real time. And all dynamic information access via CV2X. In special areas such as bridge and channels, RTK signal enhancement equipment will be added. 5G cloud platform realize the data analysis and mining function. Next slide. Conclusion. Next slide. So make a short conclusion. Large scale production of L1 and Level 2 level automatic driving begins, and the era of Level 3 and Level 4 is coming. 5G has come. Human vehicle road cloud cooperation. Intelligent transportation is heading in the future. Regulations and standards, HTML, smart highway road support are main problems of HTML application. HTML's updated frequency dynamic information access via TV12 expanded the coverage of RTK of 5G cloud platform construction are the stretched path to HTML for serious production vehicles. That is my all the slides. Thank you.
Thank you, Dr. QA. Very good presentation. We'll now go to our final presentation from Martin Hauschild, who is head of software development for BMW's My Journey business line. His team is responsible for the development of all navigation, ADAS, location-based e-mobility, and mobility services. In previous roles, he has been responsible for spearheading BMW new mobility concepts and technologies, including the development and launch of BMW's car sharing services. He started his career at BMW as a research engineer in the connected car domain. He's been strongly involved in numerous V2X projects and standardization working groups. Martin, go ahead, please.
Thank you very much, Russ, for having me. And let me also say hello to everyone in this call. I quickly scrolled through the participant list, and I was happy to see a lot of faces, or at least names that I know. So I'm in this weird times that we have right now. At least I want to wave to everyone being in here, and really happy to present together with my co-presenters. I haven't brought along a lot of slides. This is very typical for us in online meetings now, that we have only just a few slides. Yet I do want to touch on a couple of topics, specifically autonomous driving and communication. If you go to the next slide, please. It is something, if you talk really about communication, it is a huge and broad field of activity, right? I mean, there's probably a lot of stuff that you can talk about, and I want to address and maybe also give food for more discussions on three specific areas that I want to touch on. So the first one really being, if just looking at the name communication, typically, I mean, you would expect communication as some sort of technology where, I mean, it's all about transporting information from A to B in the field that we are in, typically wirelessly or mobile wirelessly. And, we as a car company, that is one of the aspects that we obviously also look at, but not so much in terms of customer features. It's more like an enabler that just has to work. And obviously, we are also relying strongly on the industry to get this technology up and running and rolled out, because that's typically something, it's not customer facing for us. We probably wouldn't be selling this to a customer. It's more about the applications that we build upon communication. But it is very important, and I kind of compare it to the plumbing of your house. It just has to be of high quality. It has to work. No one says thank you to you if it works, but a lot of people complain if it doesn't. So that's definitely one of the things that we're taking great focus on, to having that as foundation for all of our connected services. And if you know BMW as a company already for a while, we've always been very strong and forward thinking in terms of connectivity, connected drive being one of our core products. And since a few years already, all of our vehicles are connected. and rolling out LTE and even 5G starting from this year in every vehicle that runs off our production lines. Today, our products rely strongly on communication. On the one side, for customer-facing functions that we have in our cars, like connected services and those kind of features, but also enabling technologies like software updates that we start rolling out on our newer vehicles. So definitely one of the aspects, number one, is that communication really needs to be done well with everything that's happening in the industry in terms of reliability, coverage, latency, also cybersecurity, as Russ mentioned before. I think that is really something that we need to get right as a foundation for all of the stuff that we anticipate building on top of that. You might also say, since this topic today is about communication as an enabler for level 2 or level 2+ autonomous driving and up. It doesn't only apply, of course, to autonomous driving, right? But also functions like, stuff that we have in our car, Netflix streaming, audio over mobile phone, and those kind of things, they all rely on online connectivity. There is a difference, however, than to anything that we've had before, is that the requirements in terms of reliability are a huge step on top of everything that we've seen before. Just let me give you an example. Up until now, everything that we had that relied on communication in our cars, if that did fail, if we didn't receive traffic information, for example, in our navigation system, if our online radio had failed, it would not prevent our vehicles from driving. It would not prevent us from getting from A to B. With a few of the applications that we are seeing now, that changes differently. And just to give you an example, we as a company have had a little bit of a taste of what that means and how important that is to consider when we started rolling out our car sharing business. If you can imagine, in a car sharing fleet, your car sharing fleet is somewhere outside in the streets, and if people intend to rent a car, they open up the car in an app, and we need online connectivity to check for the driver's license and the credibility of the person and so on, and in order to give access to the vehicle and start the car. So we have stuff in our vehicle that rely on communications. If one of them fails, it is basically a breakdown of the vehicle. So if one of those technologies fails, it turns out to be something that makes sure that our cars don't drive anymore. And that is a big, big difference. Up until now, in other systems, we are dealing with fail-safe systems for braking and for steering and those kind of things. We have not really looked at that from a communications point of view. Because starting with autonomous driving and those functions, we're starting to get into an area where failure of communication also means a breakdown of our vehicle, or at least a few of those features in our car. That's a really important thing for us to address in the fundamentals of our architecture and our technology architecture in our vehicles. So, and let me go to the second aspect, now going beyond just communication as the fundamental basics. On top of that, it's all about applications, or a lot of the time we call it content, right? I mean, if you hear people talking about autonomous driving level 3, level 4, level 5, even more, there are a lot of people that ask me, what is it that you need? what do you need from the infrastructure? What do you need information about roadworks, for instance? We might need traffic information. We might need information about potholes, slippery roads, and those kind of things. We need a HD map, for instance. But to be honest, a lot of the times I say, and my answer needs to be, we need nothing and we need all. Because why is this? At the end of the day, at some point, we as a car manufacturer have to make a decision on when do we launch a system and don't launch a system. And we basically always start with building a system that does not need to rely on this kind of information in order to function. Because at the end of the day, if we build systems that rely on 100% reliability of information like traffic information, slippery roads, and those kind of things, I think it will be a very, very long time for us in order to roll out those systems. So I think the question about when will you roll out the systems and what do you need and when will the right applications be in place in order to roll out is something that cannot be answered in a black and white answer in terms of minimum requirements. So the way that we build our systems is that we have a minimum set of requirements and that we have to define. And from there, it's not going to be something that happens from one day to another, but we will be starting by clearing certain areas and road segments that we believe we have enough infrastructure and we have enough information in order to activate autonomous driving levels. And at the end of the day, our cars with its onboard sensors have to deal with everything that happens in a safe manner. Having said that, I think we need also to look at those applications, for instance, roadworks. Let's take that as an example, as something important for the acceptance of the system. While a car with its own sensors could deal with the fact that there's roadworks up ahead and that it has to change lanes, but seeing that up ahead 300 meters, for instance, would probably make it feel very jerky for the customers inside and the drivers inside because of knowing so late. Now, if you had information about traffic lane closures and those kind of things, what it actually does, it increases the acceptance and the comfort of the functions. And that is really where we are going to. A lot of those applications that we always talk about, traffic information, potholes, slippery roads, and those kind of things, they cannot be 100% required in order to fulfill the safety requirements, but they will be required in order to increase the acceptance by our customers and the comfort of those functions. So that is a little bit where we look into. And at the end of the day, there are also applications that we are thinking of where we need 100% availability. Just to let you, just as an example, if we're talking of automated valet parking, for instance, we need to have information from the parking infrastructure in order to make this work. Not so much on a technical level, but more on an application and business level. Imagine you drop off your car in front of a parking infrastructure and you get on your way into the airport and you're sitting on the plane ready to go. And that's when your car finds out there's no parking space for you anymore. Is it going to call you back saying, come back, please? I didn't find parking space. So that is something, there are applications in some point in time where we will need those kind of information and they need to be 100% reliable. I think basically, those are the things that we will be starting, not overall rollouts, but in certain areas. Talking about parking services, for instance, we are anticipating rolling out into real production vehicles, a level 5 low speed automated parking service very shortly. but not available to customers. But for instance, in our logistics and our factories, in order to shuffle cars around, for us to try out those kind of functions in the future in closed and in confined spaces. Let me now come to the third aspect that is also, I think, very important going forward. Autonomous driving, I think, is not only just to replace the driver. So, I mean, there are features that we try to replace drivers, or we try to alleviate drivers from boring driving jobs in traffic jams, for instance. But what we also need to consider is the effects that those features and those functionalities have beyond just the individual vehicle. We need to also look at the collective effects of those kind of features. For example, and that's also a thing that you have to put into context when you're talking about applications for autonomous driving. Let me just give you an example. In a level 5 scenario, where you're talking about robo-taxis and you are calling a vehicle that is located about 10 minutes away from where you are right now, and you're calling that vehicle to pick you up in 30 minutes. We need to find out what strategies to put in place in this kind of case, for example. Now, I said that this ride is 10 minutes, but you want the car to pick you up in 30 minutes. So what do you do with the delta of 20 minutes? Should the car wait in its destination? Should it wait in its origin? Or should it maybe calculate that when it wants to arrive in 30 minutes, all it needs to do is start the trip with a traveling speed of 7.8 kilometers per hour? I think that would be something that would make a lot of chaos in our cities. So other than, as I said, we need to deal with the basics on a very fundamental level of communication. Then we need to deal with, applications on autonomous vehicles, the content that we need. Is it something that we require? Is it something that enhances the feature, it increases the acceptance? And then on top of that, one of the things that we look strongly into, and which is important, is how does the technology that we develop look from not only an individual perspective, but also from a collective perspective. So as I said, as I started, I want to close my statements with a summary saying this is a field that is very, very broad on all levels of technology, from the basic technology to applications that we've heard a lot today. There's a lot of research going on, but we are still far away. There's a lot more to explore in terms of also the effects and the effects on society and traffic. And I think it is important to look at all those aspects of autonomous driving when we go forward. So thank you very much.
Thank you, Martin. These have been very good presentations. At this point, now I want to start with the answers to many of the questions. I see 14 that are in the Q&A, and have Nakul start by answering some of the key questions. Nakul, one question, a set of questions, is about how the communications are going to get to developing countries, Africa, and other places, and in particular, what will be the ability, and when will we see the ability for some of the things like medical and other emergency type structures to have the technology that we need?
Yeah, good morning, good afternoon, everybody. Very nice to be with all of you. Look, I think as Martin was mentioning in his remarks, uh, the way that the applications and the opportunities will emerge is really very difficult to predict because there is just so much of a clean sheet in terms of how new problems can get solved as you combine automation and low latency, high bandwidth real-time connectivity. To address your question about the pervasiveness of communications, what we are now seeing as 5G starts to get rolled out is the fastest ever wireless transition in the history of the wireless ecosystem, where within 2.5 years of the standards getting finalized, actual deployments on the ground. Through the pandemic, I think that pace has continued unabated. And, I think it is common knowledge now that every new vehicle is highly connected. It's connected with the high-speed connectivity and low latency connectivity. We are very excited about the potential of V2X and especially cellular V2X through this transition because it, first of all, is a complementary sensor to all of the other sensors that driver assistance and automated driving requires. It requires close coordination with regulatory bodies, transportation bodies, but the value that V2X brings to the existing environment from the perspective of informational safety is very huge. You can add an additional layer of intelligence into any environment by combining information that has to do with presence, that has to do with situations that are unexpected into really any situation, making the overall transportation system much more intelligent. Your question about developing markets, one thing that we have seen, independent of really automotive, is the pace at which wireless technologies have been embraced in developing markets is in some cases much faster than even in developed markets because it is a greenfield opportunity. We saw that with 4G, and I expect we will see that with 5G as well. Once again, in the context of how communications and automotive driver assistance overlap, we are already seeing in China, after CV2X has started to become accepted, that informational safety by intelligent highways, intelligent intersections, communicating to cars that have V2X capability enabled, increase the overall level of awareness of any impending collisions, accidents, and so on and so forth. So I think that there is a tremendous amount of potential as you start to think about next generation communications technologies and the use cases that they can bring into existing driver assistance and in the future automated driving scenarios.
Can you clarify what's going to happen to the old DSRC 802.11p technology?
Look, I think, in the world of communications where we are at the cadence of developing new technology standards, embracing new coding schemes, thinking about new use cases almost on an annual basis, what is very important is to be able to think about the foundational technology that has the capability of surviving for a very long period of time. And this is why we invested heavily in the release 14, release 15 versions of CV2X, which give you that foundation. And for me, foundation means that you have the ability to deal with congestion. You have the ability to deal with very highly dense environments. And then as more frequency spectrum is available, that capability scales up. So we spent quite a bit of time making sure that that was designed correctly.
Then as you layer up newer variants, newer versions of the standard, the important thing then becomes, how do you add new use cases? You had asked in the previous question, Russ, about emergency vehicles, first responders. How do you bring sensor sharing at high speed and low latency into the mix? These are the types of things that Release 16 has tried to address. We are in parallel looking at how do you bring vehicle to pedestrian or vehicle to other vulnerable road users as very key use cases that can be solved through communications as yet again a complementary sensor. I think for us to be able to move in this direction, we look at the 3GPP space really as one area where there has been a tremendous amount of technology innovation in the communication space that has taken place over the last many years. And it's a very ripe environment for similar innovation to take place. So that's been our reason in terms of why we have spent so much time and focus on cellular V2X. I think that there are deployments that have taken place in the past to solve specific point problems, whether they be tolling or basic communications. But if we are to map out a roadmap that is based upon next generation communication infrastructure, communications technology, I think we need to be on a platform that gives you that evolution path, and those are our choices.
As you know, China has moved completely to cellular V2X. U.S. Federal Communications Commission has determined that cellular V2X will be the only technology going forward. What is going to happen in Europe, where there seems to be no decision between their what they call ITG5, which is the 802.11p, and cellular V2X?
Yeah, so we continue to work with the appropriate folks in Europe. I think here would be my view on the situation overall. As we talk to automakers, both from the perspective of their assessment of the technology itself, and we started having these conversations 3, maybe 4 years ago, at which point V2X was understood, but not necessarily in the context of the scale and the applicability. We saw a certain set of opinions. But over the last few years, as 5G has become central to how automakers think about their next generation vehicles and the importance of connectivity in the vehicle, the realization is set that it is very important to have standards that are harmonized, that allow you to be able to think about applications evolving in step. We are engaged with a number of automakers now who are protecting for a multitude of technologies, or at least 2 technologies, given that becomes in some sense a minimum requirement. At the same time, what I would say is that we are seeing China move much faster in terms of embracing the capabilities that V2X can bring across a much larger footprint, much larger number of vehicles. So my view is that once we get to an inflection point where the core value of cellular V2X is going to be on display, I think it will definitely drive a number of markets to start to think about the connection between large-scale 5G deployments that are happening really across every single network all over the world, and what choices have been made on the V2X side. Will there be a period of time where there will have to be some coexistence for decisions that have been made in the past independently? Perhaps, but it will have to be looked at in the context of how many vehicles are these, how long do they have to be supported, is there spectrum to be able to add additional capability and newer standard, how will 2 technologies coexist? All of those complex questions definitely remain. But I would also say that in Europe right now, there is the rate at which V2X is growing is still slow. It is still in the very early days. And 5G is expanding very quickly across most networks in the US. So I do believe that there is ample opportunity for us to be able to be on the cellular V2X path. I think we talked about China. In the US, we are very hopeful given the focus that the new administration has on infrastructure and on 5G, that we start to see cellular V2X deployments.
The key part of this session is communications for automated driving systems in series production vehicles. An underlying question is, when will we have series production vehicles start to be deployed on the market in at least highway speeds? As you know, Reg 157 only goes up to 60 kilometers an hour. It has to be extended to reach 120 kilometers an hour and allow lane changes. While that proceeds, how long will it take the vehicle manufacturers to start having their series production vehicles ready to roll out the full highway automated driving systems? And then will the cellular and other communication CV2X be a gating item, or is the gating item the actual technology, underlying technology itself, and that the communications will be ahead of the actual ability for vehicle manufacturers to create these highway automated driving products?
Yeah, so maybe a couple of questions packed in there. I think the timing for highly automated driving features, highway autopilot at high speeds, those features vary in terms of timing and in terms of the content of the feature by region and by automaker. I think there are a few that are available today, but I expect that in the 22-23 timeframe, we're going to start to see these features available from mass market automakers, some of whom we are working with. On your question of how V2X intersects these features, what I expect to see are really two different scenarios that are at work. One is where there is no direct intersection between the V2X systems and the highly automated systems, because V2X will operate as a complementary informational safety sensor. If you assume a scenario where you have a highway that is capable of V2X intelligence, V2X infrastructure, the ability for the highway to be able to share in real time very hyper-local information around construction, around weather, around accidents, is going to make the car a whole lot more aware about things that its onboard sensors cannot see, but a wireless sensor can easily provide. And that would be a driver assistance function. Now, over time, can something like that be built into the onboard logic such that actuation is affected? Yes, I think that will start to happen. But it assumes that there is a base amount of capability in the infrastructure for such a capability overall to exist, number one. Number two, you need network effects in terms of vehicle to vehicle or vehicle to X communication when you want to really start to get to the much more comprehensive integration of V2X with automated driving. And that assumes that there is a large amount of deployment across cars, across other endpoints. And that, I think, is clearly going to be taking some time, because you have to be able to get to that critical mass, that network effect. But I think the infrastructure to vehicle communication is a very powerful capability that once available, and threshold to make that happen is significantly lower, I think works very complementary manner to onboard highly automated systems.
Okay, I'd like at this point to give my fellow panelists the opportunity, if they have questions that they would like to ask Nicole. Please, panelists, speak up if you have questions that you would like to ask Nicole at this point. Please do ask those. So I'm afraid everybody is intimidated, but please don't be. And if you have questions, please go ahead now and ask them.
Yeah, I might ask a question. I was just wondering what your view is. I mean, we're always talking about cars, right? Cars and maybe trucks in terms of autonomous driving. I would wonder what your opinion is on other forms of, applications, be it transport or anything else like logistics, that we might also see coming up. It might even be a quicker rollout than in passenger vehicles. For some reason, we are always very focused on the passenger vehicle, right?
That's an excellent question. In some discussions, one of the areas that we've focused on, where interestingly, the entities in most states and most cities that are responsible for traffic and transportation are usually the state, and they have a lot of state-owned vehicles, whether it is utility vehicles, emergency vehicles, law enforcement vehicles. And these are really the platforms where the capability can be deployed much faster. So we've actually, a lot of the trials that we have been involved in are actually in concert with some of these nearer term opportunities where frankly the value is also a whole lot more. The complexity really comes in the sense that there is a chicken and egg, which one comes first? There are several aftermarket solutions that you have to think about if you have to deploy in vehicles that are already on the road. But one very interesting phenomenon we are seeing is that a number of OEMs who we are working with on the passenger vehicle side, they also build a lot of specialized vehicles where the applicability of what you're suggesting is much higher. So I think that actually connects quite nicely. The other area that we are spending a bit of time is VRUs or vulnerable road users. To start off with bikes, scooters, motorcycles, and then of course, eventually pedestrians. It is a very interesting area because what we are seeing here is that there is a layer of intelligence that is required beyond just the communications layer. And this layer of intelligence has a lot to do with crowdsourcing, a lot to do with the availability of information, depending upon the specific area. For example, today there are plenty of maps that will tell you what the average speed is on the highway because they're able to crowdsource information from various phones that are in that area to understand at what speed you have cars moving. One thing we are thinking about is how do you add an additional layer of intelligence where if you could find a correlation between vulnerable users in an environment where they may clearly not be visible to a vehicle, but you create a layer of intelligence that is a combination of crowdsourcing and actual communication. Does that improve the opportunity to be able to avoid fatalities, collisions, etc.? So there are a number of different tracks that we are looking at. Some of them are very communications oriented, but a number of others are actually really oriented around overall context in that environment. And how can you take advantage of communications, but then do something, quote unquote, out of band to bring additional value.
Okay, Nicole, what is the role of the network operators in how we evolve the communications for automated driving? We spent a lot of time talking about the vehicles and the vehicle manufacturers. Where do the network operators fit in?
Yeah, I think it's an interesting question, and I think there are at least two facets to it that I think need to be looked at a bit more closely. I think one is the overall. I think one is very specific to the market or the region that you're deploying in. So if you have a market where the network operator is also very tightly involved in the overall infrastructure modernization of the market, where you have reach all the way down to the intersection, and you're able to bring about a lot of capability down to the neighborhood, down to the streetlight. That creates a very powerful construct in terms of being able to influence the needs of highly automated driving and of safety where it is required from an infrastructure perspective. As we know, different network operators are have different capabilities depending upon the markets that they're in. But where there is such an opportunity, then the infrastructure in our mind essentially becomes an extension for yet another service that the network operator can be a part of, which becomes essentially a traffic service, a safety service, and potentially a highly automated service. So that is, kind of one way to think about it. Now, there are many markets where the operators for transportation services, road services, etc., are completely independent entities. They have really no direct correlation. And in those cases, the role of the network operator mostly becomes the more typical: provide the infrastructure, provide the network capabilities for bandwidth, for communications, with 5G, offer a network slice for dedicated services. The third piece, which I think is important to think about, is monetization. How do you monetize? How do you come up with a business model that allows you to be able to combine the need for safety services, which are likely going to be on an unlicensed band for direct communications, with cloud-based services in CV2X UU link services, which are really running on more traditional licensed or an operator licensed band. Then is the question of creating an actual services plan where the network operator is able to offer a combination of these capabilities. So I think the reason this is complex is for all of the reasons that I explained. I think it really comes down to how this gets implemented from the top down. One simple way to think about it is in layers. Once you finalize what the spectrum strategy is for the V2X, and you know how to go roll that out, you know who the players are that have to go deploy infrastructure. Then being able to create a partnership with network operators where they're able to build a traffic service or a safety service on top of that underlying V2X service becomes straightforward. So things have to happen in a serial order for there to be a way to actually get this capability off the ground. If it is done out of order, there is obviously complexity.
Final question for you, Nicole. How are we going to get the required accurate positioning for the communications to be able to, for example, with vehicle to pedestrian, pedestrian to vehicle, know which pedestrian is at risk or a vulnerable road user for which vehicle?
It's an excellent question, and one that we were discussing just earlier this week internally. Look, I think there are two facets to the question. I think one is what is the best position that you can derive based upon the endpoint that you control. So if it's a phone or if it's a car, the more sensors that you have in that phone or that car are directly proportional to the quality of position that you're going to have. We've been working on a technology called VEPP, Vision Enhanced Precise Positioning, that takes 4 different position sensors. It takes multi-frequency GPS, it takes camera information, it takes various onboard sensors, gyros, and it takes the inertial odometry information and combines them and is able to get to a very highly accurate position, centimeter level accuracy on high definition or even a sparse definition map. But it requires more sensors. Now in a phone, I think in typical open sky type environments, you are able to get to, meter level, maybe multiple meter level accuracy. And this is where I think, like I was mentioning in the previous question, what becomes very important is to be able to also have crowdsourced information. So you have to be able to think about VRUs in the context of where they are. If you are in an environment where the typical density of foot traffic is much lower and car speeds are higher, you have to be able to correlate the presence of VRUs with that environment and make a certain decision. Versus if you are in a highly dense environment, downtown, a lot of people around, you have to be able to have a different type of decision making in terms of how do you correlate the presence of a lot of vulnerable road users. So what it really comes down to us is location is just one input into the decision-making logic. You have to combine that with a variety of other inputs that typically would require a level of crowdsourcing, but then also additional inputs in terms of time of day, how much traffic is there, what is the speed at which traffic is moving. A number of those factors have to be brought in. And it is something that we are having a variety of conversations with a number of different stakeholders on the mapping side, on the handset OEM side, of course, on the auto OEM side, to be able to figure out how do these various layers of logic come together.
Okay, thank you very much, Nakul. It's been now 2 hours on this. I'd like to let everybody take a 5-minute break, and then we'll come back with more discussions with the panelists.
Thank you very much.
Okay, let us resume where we are and start with the further discussion with the panelists. We have a few questions. We certainly welcome more. Before I start on questions, I'd like to answer what is obviously a misinformation for some people from the questions. For cellular V2X, there is no wireless charge. Cellular V2X does not go into anyone's wireless bill. It is not a cost. That misinformation, particularly in Europe, among authorities, has been floating around. Cellular V2X, by its nature, going through 5.9, not through regular cellular, does not have a charge. So hopefully at some point we can overcome that kind of misinformation. All right, now I'd like to ask the panelists, and I'll start. We've had very good discussions and lots of questions that come around to their structures of what's going on and where we are. I would like to ask panelists, they all come from car companies who are looking at rolling out automated driving at some time, for an estimate of when the actual rollout in production vehicles that consumers will buy for the highway pilot type structure that was very well described in the presentations. When can we expect that for first high-end cars probably, and when will it be available across a wide range of consumer vehicles? So panelists, please turn on your webcam and turn off mute and give me your ideas on this question.
So I just let me start. If you're asking for a number, you know, I mean, typically in car generations, we move along the lines of our, you know, technological generation. So I think looking at our company and also others, I would expect 2023, somewhere between 23 and 25. To see those applications on the road for real customers to buy. The only thing that I probably would not bet on is describing the function and the application that we will see. You know, is it going to be a commute pilot that takes you up to 60 or 80 kilometers? Is it something on a free highway to 130? I think that also depends a lot on legislation and those kind of things. But my personal belief is that we'll see those things coming up to the road by 2023.
Okay, Ogawa-san, what do you see for Japan?
Yes, in Japan, as you may know, the Honda is the start production last year. This year, the already selling the vehicle with the traffic jam pilot, but still the limited amount of the vehicles only sold. Therefore, the and also the vehicle price is very expensive. Therefore, the mass production will be not soon, I think.
Okay. What is the view from China? Dr. Mayoung, please go ahead.
I think this year and maybe next year, and TGP and HRP will be realized for some OEM. And I think because the CV2S it is difficult to make sure the safety. So currently the HRP or TGP can only depend on the vehicle and the self and the sensor to realize and maybe in the 2023 or 2024, maybe for high level HRP and TGP will be realized there.
Fan, do you have an idea for how it's going to roll out?
My observation is that like maybe the traditional OEMs and the new OEMs in China, like NIO, like Xiaopeng, I think these two type of OEMs, they have different strategies. Like NIO, they will have very strong sensors and the new architectures, and they alongside they will realize the HWOT very soon. It may be like the 2022. This is what we may observed. So they are very aggressive, and also the traditional OEMs are also very aggressive. In fact, that's my observation. But the difficulty is that whether your customers want to purchase the vehicle with that high level autonomous driving. As I mentioned, for example, like the Chang'an's car, for our current brand, that's the price of the vehicle is from $18,000 to $23,000. So if we have such kind of high level autonomous vehicle in that brand vehicle, whether our customer will purchase it or not. So it's not only a technical wise topic. If you want to make that a massive production, that depends whether your customer really want to accept it. So for the traditional Chinese OEM, if it's still the existing brand, like we call it the middle or low brands of those OEMs, I will say that's maybe also after the 2023, but for the new OEMs, they may have an aggressive plan, maybe around or before 2023, like the 2022. That's my assumption for their roadmap.
Okay, thank you.
Yeah.
What are the what is the one most important issue to overcome in being able to deploy highway pilot on a wide scale? Dan, why don't you let you answer that first?
You mean wide scale means a massive production?
No, area. Sorry.
Area.
Yeah.
Um,
We have lots of tests on a few highways in some cities. For production vehicles, you really need to work on at least all expressways. So,
my opinion is that how we define the how to say, advanced or high level of autonomous driving, how to define it. If we will see that means the eyes of system like the HWP, TJP, I still think that take a few years, frankly, to say that's my personal view, because you really want to have the eyes of system that you need to have the reliability and the robustness and even the duration, right? How to say, it's very reliable to the system to release the vehicle to the market. So I think like the Chinese government to try to promote some pilot areas, testing pilot areas, it's trying to promote the industry, like the communication chipset, and OEMs, and they're trying to have some research and develop. But for the mass production, that because the OEM have to take that responsibility, right? So the OEMs might be very cautious to release such kind of system, say that it's a really eyes off system to the market. So yeah,
I very much agree with you. As I would describe things, what we're trying to do with an automated driving system is eyes off, but as we would say it in English terms, butt in, that still the driver has to be seated in the driver's seat, but can at least do email or other things. That's the structure that I think we're working for. And I would just like to note for all of the audience, SAE that has provided the 5-level definitions that most of us know, will have a updated version of their definitions of the levels of automation published in a few weeks. It's been done in cooperation with ISO TC22, and that will have more variance and details in how things would be structured. So let me go back to my questions. Ogawa-san, for Japan, when would you see a highway speed rollout across Japan on expressways? You mentioned the early announcements for companies like Honda that will do the initial regulation 157 up to 60 kilometers an hour. When do you see rolling out in Japan at full highway speeds with lane change?
The Honda executed the lane change in their product. But still under 50 kilometer, starting from 30 kilometer to 50 kilometer, just the only traffic jam. Is it the answer for you?
No, I want to try to put you on the spot. Just as a guess, when do you think there will be systems that will go to the full speed limit on Japanese expressways?
I have no idea.
Okay. All right, I will leave it at that. To go back to earlier points, I still see questions. Understand that cellular V2X does not use the network mobile operator. It is direct device to device, and that level of confusion is there. I think we will be looking at evolutions of cellular V2X that will allow various things like IPv6 and other things. And for all of you that are interested, as Martin, I mean, as Stefano mentioned earlier, the meeting tomorrow on the collaboration of ITS communication standards will have a full discussion in detail of these points. And all of you who are interested, I suggest you register and take part in those presentations and those discussions tomorrow. All right. There's a number of questions about infrastructure. So I'd like to ask the panelists, what kind of infrastructure and how much infrastructure do you think is needed to support automated driving systems? Martin, why don't you start?
So it's hard to say. As I said, you know, as when we come from you know, the engineering side, we will not design a system that relies on infrastructure. We will come from the end of trying to design a system that is autonomous and that relies on its own sensors. But obviously, you know, infrastructure very often compared to, you know, being a sensor also, to see stuff that onboard sensors cannot see. So I definitely think in terms of, you know, not as a prerequisite in order to operate autonomously in a safe fashion, you know, not killing people and those kind of things, but more to implement a system that is acceptable by customers and that will be adopted by customers. So I think that the important part is that we have infrastructure information and infrastructure sensors that go at least where we have it today, right? Like information about the roadways, traffic information, information about, you know, traffic and constructions and lane closures and those kind of things are the minimum that we require in order to build a system that is just acceptable to our customers.
Okay. Other panelists have ideas, like Mayo Yan. What do you see for what FAW is doing as needed infrastructure pieces?
Okay. I think the infrastructure is important. Yeah. For example, in the tunnel, the GPS RTK is not the signal is there is no the signal RTK GPS and RTK signal. So there are needed some device enhance the GPS RTK coverage. And also, some for the road construction and traffic accident. This information, if the situation can be provided by the road the side unit here. Also, I think it's good for the automatic driving. So For the road construction and the traffic accident, the information provided by the device also I think can be realized for the infrastructure.
Okay, thank you.
Okay.
Other panelists have comments to make on this question? Okay. Let me go forward. The next question, one of the questions is, what is the latency that is going to be needed for communications in automated driving? Ogawa-san, what is SIP looking for in the way of latency for different types of automated driving?
Yes, and as I mentioned in the presentation, we established 25 use cases. Some of them need low latency, and some of them they allow the latency. Therefore, it's depend on the use case.
Yeah, so for the use cases that require low latency, like say pedestrian to vehicle warnings, what latency would you like to see?
Actually, we eliminate V2P, pedestrian, the two vehicle use cases are not suitable for our use case, because the SIP researched the V2P the last 4 years or 5 years, but we have a lot of issues. Still, we have a lot of issues to regarding the vehicle location measurement. Therefore, the V2P is not is not will be not the use cases, and the low latency. We should have the collision avoidance and the traffic signal information.
Okay, for those applications, what kind of latency are you looking for?
It's the amount of latency.
Yes.
The Japan Automobile Manufacturers Association required 300 milliseconds for the traffic signal information.
All right. What is expected in China for these low latency applications? Fan, can you answer that?
Yeah, let me try. Let me try. Yes, I think definitely it's decide by which use cases. we will see if we have the voice collision mitigation applications, no matter it's a warning or have you want to break. I think the latency should be at least less than 0.1 second, because or else that the information is over time, that is useless, or even cause more troubles. But if we are talking about, as we mentioned, like the OTA software update, it's not that critical, right? So that is why we're thinking our current 4G or 5G signal communication is enough. And if you want to have some update to some information like the traffic jam on the road, it also doesn't require such kind of short latency. The information is, for example, like the 1 minute. I'm thinking that's enough, because what we have for our dynamic map, the information is around, we'll update it every 2 minutes. So I'm thinking if it's traffic far away from you, that's really not that important. So the information update, if it requires only like a minute, it's I will say it's not latency, but it's just required that the information update every minute. I'm thinking that's enough. So that's my humble opinions. Yeah.
Very, very good. Mayoyan, your ideas?
I think it depends on the different case. Yeah, for highway pilot, I think let me make a sample. Assumption: the vehicle, the autonomous vehicle, the speed is 120 km/h. It means 1 second. The autonomous vehicle will reach 33 meters. It means so I think the latency must less than millisecond. Maybe the several milliseconds, maybe 10 milliseconds. 10 the millisecond. Because even though the 10 milliseconds, also the autonomous vehicle will go the 3 or 4 meters. So I think for the if we use the road construction and the traffic accident signal sent by CV flags, I think several milliseconds must be reached. Then the information can be used by autonomous vehicle.
Yes. Okay.
That's all.
I think that's very good breakdown from the two of you, that there are a wide range of requirements depending on applications, as I would see it. Things like software updates over the air, those are requiring normal communications times for dynamic data, as we talk about traffic jam ahead or slippery roads, maybe down to 1 or 2 minutes. And certainly if we're trying to do dynamic control, as mentioned, the key number that I tend to work with is vehicles moving at 30 meters a second. Even a tenth of a second, 100 milliseconds, is 3 meters. And that can do a lot of damage in an accident. Martin, your ideas?
Yeah, so I absolutely agree with what everyone else said. It's definitely a difference depending on the application, and right down to even if it's really safety critical and time critical, up just a couple of milliseconds. I think, what the other issue is, when you talk about latency, is also level of service. So basically more the consistency of latency, not only the absolute number, right? That you get in peak performance. That is probably maybe even more important than the absolute number in latency, to get that guaranteed level of service. Because if you just look at the absolute numbers, I think you'll probably find that almost all applications, maybe just a very few exceptions, are fine with latencies that you have in technology today, right? Even 3G and LTE, you don't even have to go up to 5G. But it's more of the consistency and the reliability and the guarantee of a certain latency.
Okay, thank you. Meiwan, in your presentation, you talked about the update cycles for HD maps, and trying to move that from quarterly to monthly to weekly. What consideration has there been in China to, instead of using traditional mapping type structures, to move to a vehicle sourcing type structure where the vehicles themselves create and send the updates to the map, possibly through a server still, but that the updates get made automatically from the vehicles driving?
For the HD map, so I think there are several the process there. For the map maker, first for map maker finish the updated the HD map. Also, it need the improve by the government, and also this is this need the time. Currently, for the map meter, and the frequency it's quarterly, and in the quarterly will also the government will improve the for the HD map license, yeah. And in the future, I think the map approval will be improved, and maybe the approval will be automatically. So I think the time can be reduced there.
Okay. You're right. I understand that China government does approval of map updates. I think that's a China only situation, and that the rest of the world does not require such approval. So we will have to wait and see how those things evolve. But that's a very important piece in considering automated driving systems in China. So all of us who work in other markets need to remember that the rules in China are different. Martin, let me go back to vehicle to pedestrian. What is your view on, will there be ability to have pedestrian to vehicle warning type systems sometime in the future when we have accurate enough positioning of mobile phones?
I think generally yes, because of course vulnerable road users is a big topic. Obviously, I mean the question really is, are we going to have technology and also business models behind there that allow for wide scale of something like this, right? Just to give you an example, mobile phones would be one sort of sensor, but I've been recently approached by a company that had the idea of building a 5G enabled bell for bicycles. And if the person rang the bicycle bell, it will show up in the head-up display of vehicles, so that drivers would be warned. While this is an interesting idea, and I think it is a technological challenge, but that's something that can be solved. But how does the scenario look like of being rolled out commercially? Because I mean, a lot of this works or does not work with the adoption in the market. I mean, if this is something that happens and that is available, but you only see some person like this once in 10 years, it's just not going to happen, right? Really, the question is not so much in terms of technology. I think we're gonna get that done as engineers. The question is more: is there a economical scale scenario that we can see?
I think you're very right on that, and unfortunately, we've had much publicity, articles, maybe some IT companies coming up with the view that automated driving technologies will be fast and coming soon and what have you. There's many issues that I think, as you said, the technology will happen, but the timeframes may be much longer. I think we generally know how to, we will in the next few years be able to position vehicles within about 10 centimeters relative to a map, though that's not relative to the real world. And those kinds of technologies relative to a real world are more in the 0.5 meter to 1 meter range as we're looking for, which is even for collision avoidance still a pretty long ways. So I do believe that someday we will have these technologies solved. I would be surprised that we have things like a good vehicle to pedestrian system. Not only it won't be this decade, it may well not be next decade, but sometime, just as we've looked at how mobile phones evolve and technology evolves, sometime 2035, 2040, sometime we will probably have precise positioning in some device that people, bicycles, and others can carry. The problem that I think we have to work from is we need to be able to separate ideas to practicality. And the IT and communications world, we know with mobile phones that we have grown to accept, well, maybe there's a hiccup, maybe there's a problem, maybe it doesn't work too well. Unfortunately, we've seen some Silicon Valley type companies putting things out in cars that are more IT oriented, where they make mistakes and they kill people. And I think that's a problem mainstream vehicle manufacturers have to face, where mistakes kill people in automated driving. Martin, do you have an idea of how, like in BMW, you address pressure on one side from these new technology oriented companies to put things out that have less reliability versus what BMW will do?
Well, I mean, you are absolutely right. This and you're tapping on an issue that I think every big OEM has, since we are kind of competing in a field where we have very different companies of different nature that are producing the same kind of functionalities. And obviously a tech company, a startup company, has much less to lose than a big company like BMW, right? So I think definitely we see what is happening out there, but at the end of the day, we as a big company have to find our own way in adopting those technologies and setting our standards of reliability. And yes, that may seem like we are moving slower than others, but it is just a different context, and you just cannot compare one company to the other. So I think at the end of the day, sometimes those companies that are out there and have a much lower threshold in terms of safety and their own reputation, they might help the industry in itself to push forward and also help society to learn about those technologies. But then, for mass market, I think we are all then at the end of the day cooking with the same type of water and then we're going to see what are the technologies and when are they mature enough in order to be put out in the market as a mass market function.
Mayowan, Fan mentioned the new manufacturers in China with very advanced technology, at least as they present it. How is FAW dealing with companies like XPeng that say they have automated driving ready versus what your company may do?
Sorry, I didn't come in point.
Yeah, I think as we said, there's new automotive companies, new technology companies like what we call in US XPeng as a electric vehicle manufacturer with advanced technology and very high market value right now. Those companies, XPeng, NIO, others, all are saying they have automated driving in their vehicles or coming soon. How does your company, how does FAW deal with those technology-oriented companies that say they have advanced technology?
Okay. Basically, yeah. For FAW, I think we take the two ways to realize the autonomous vehicle. Yeah. For serious production, vehicle, we for level 1, level 2, and level 3, yeah, we go this way. Yeah. We will step. We will go step by step. Yeah. So such as the TGP and the HRP will will realized. And for in the other way, yeah, we also make the new technology such as AI technology into our level 4 the autonomous vehicle such as robot taxi. And also we cooperate with the new the IT technology company to cooperate to realize the high level autonomous vehicle.
Okay.
Okay.
Thank you.
Thank you.
There's a question that I will try to answer. The traffic improvements for signals is one of the areas where we can potentially have a significant impact. And the question that's asked, is there technology now that would provide traffic signal information, signal phase and timing as we talk about it? The short answer is yes. Cellular V2X unequivocally can provide the ability to do traffic signal system broadcasts. The problem that exists mostly on this is, as we would say in American English slang, chicken and egg. The vehicle manufacturers don't want to put the capabilities in their vehicles until there's a substantial set of traffic information, traffic signals that are broadcasting the information. And the authorities doing the traffic signals don't have a lot of spare money and are not moving forward to put the communications technology into their traffic signals, even though a fully hardened cellular V2X system is available at a very, very low cost now. There have been tests, for example, Audi in the Ingolstadt area has been testing the technology, but we have a strong problem overall, and this is what I want to leave as the last thought in this session, is that the authorities need to do some things, and the vehicle manufacturers need to do some things. And unfortunately, we have a difficulty of how we do the coordination between rollout in vehicle manufacturers and rollout in authorities. Most vehicle manufacturers do not want to put systems in their vehicles that will not have much use, and most authorities don't want to put out systems that have little use. So both wait on the other, and we have not figured out how to move things in parallel. That will be a subject for additional discussions. I want to thank my panelists. Very good contributions, very good presentations, very good answers. And I'd like to turn over to Stefano to wrap up as we're reaching, by my clock, the 4 o'clock hour in Geneva is about on us. So I thank everybody, and Stefano, please finish.
Thank you very much, Russ, for today's inspiring session, and thanks to all panelists, Ms. Fan, Norifumi-san, Martin, Maoyan, as well as Nakul, our keynote speaker today. Connectivity is the key feature to enable highly automated driving, and this symposium highlighted the importance of collaboration among the automotive and the information and communication technology industries. And this is well reflected by the ongoing collaboration between the ITU and the UNECE. Ladies and gentlemen, the symposium has successfully concluded. I would like to extend my gratitude to the Symposium Program Committee who made this happening. In particular, Russ Schild, Roger Langlet, and Michael Sena, who have also moderated the session, and my colleagues at UNECE, Walter Nissler and François Guichard, for their excellent collaboration. Many thanks to all panelists, keynote speakers, and moderators of this year's symposium, as well as all attendees who have joined us. Also, I wish to thank collectively all my colleagues in the ITU that supported this event, organization, communication, marketing, and administrative issues. Big thanks are due to the ITU Standardization Director, Mr. Shesab Lee, for hosting this symposium series. Finally, sincere thanks to our sponsors, Qualcomm and Xperi, for their generous help. I hope the symposium will find its natural home at the Geneva International Motor Show next year, and I hope to see all of you there. This is Stefano Polidori from the ITU. Thank you all for joining. Stay safe and see you at the Symposium on the Future Networked Car 2022.